It is Final Friday, so we can say welcome to Hanoi with RAKStars once again. Hey Jose, how you doing?
Hey Maria, how's it? Yeah, how's it been? Been a crazy week, right? We reached
Yeah,
5,000 members on our RAKStars Discord, which is an amazing milestone. I
thank you
think we
for
started
you all
1 year
for
ago,
joining.
right? In October last
Exactly.
year, we
We
were
we
building it
started
up.
our Discord 1 year ago, and 1 year after, we have more than 5K
It's,
members on the Discord community, which is
yeah,
awesome.
never imagined last October. It's
Exactly.
great. Thank you all for joining us on their really amazing
Definitely.
journey.
And yeah, like this space is all for you, and thanks to you. And if by any chance someone of you is joining for the first time for this session, we are super happy to have new members around. As always, this is just a community space where we share with passionate RAKwireless community members, or as we call them, our RAKstars. And it's just to share about their projects, their hacks, and many others experiences in the IoT industry. So yeah, that's like all for like kind of an introduction. And in today's session, we're going to be chatting with a telecommunication engineer who is super passionate about technology as an engineer, we can say, and also about open source arts and for hand cultures. He has a really interesting background. We're going to hear a little bit more about him in a bit. Also, he joined us in a previous session, so we have a lot of details about him. But he's a person who always love to be learning new things and testing new technologies, but with the aim to mix classical automation and Internet of Things. And his name is Xavier Florensa. Welcome, Xavier.
Hi,
Well,
nice to be
hello,
here again.
welcome again. Yes.
Again, yeah, we have you again on the stage. We can say that like you have been, there have been some changes on your side, and also now you are more focusing on the IoT part of the project, which is pretty awesome. And yeah, like as you just mentioned, you have been already here, so we can say that we already interview and we talk in more like deep about your previous experience, different projects you are currently working on. However, all the things that has been happening bring us to the topic that we have today, which is like the use of IoT and LoRaWAN technologies in the industry. So we would love to hear about the updates that you have for us. So just before I start jumping to that conversation, just a brief introduction about yourself once again will be super nice. So can you share just a bit about your background, our education, and how did you got into this world of IoT?
Great. So, yes, I'm a telecommunications engineer with passion for technology and electronics. And I have been always tinkering and more with more activity the last 4 years. How did I go into the IoT world? I remember having a bill of the water company, water utility company, because something was broken, some pipe was broken, and I had a huge bill to pay, and I have said, I have to fix it. I have to fix this. Then I started to think, and that's how come all this revolution in my life. This is IoT and all the maker world and all this.
And
So
and
then,
and I'm wondering, like, how do you fix that pipeline when you were start thinking that?
well, first of all, was to cut the water supply, repair it, and then prepare for next time with something with a Raspberry Pi. I just installed a water meter counter with pulses, and the Raspberry just counted directly with no interface, directly the water meter with 2 wires to the GPIO of the Raspberry Pi. So easy. And then just making first the program in Python, then came Node-RED, and later on LoRaWAN. So now I always have an alarm if the consumption of water is higher than 300 liters per hour, I get an alarm. So
Awesome.
I'm safe in this way.
That's nice. That's nice. And also, like, we can say, well, since I can notice, like, you have been using a lot of Node-RED for the different projects that you have been implemented, right?
Yes, I love Node-RED.
Why? Why do you love Node-RED?
Well, because it's easy to program for non-programmers. You don't have to have a big knowledge of computer science. There are lots of nodes already made that you just connect one with the other, and everybody can send an email from the machine, or send a telegram, or even it's easy to inject on a database without knowing so much about databases.
Exactly.
It's amazing.
For those who maybe don't know about Node-RED, it's basically a tool that helps us to interconnect like our devices with different services in a pretty easy way. It's like a float mode interface where you have like different nodes, blocks. I think if they call nodes or blocks, I think they're called to date.
Nodes.
Nodes, yeah. And you just need to, like, what do you need to receive from this? Then you need to parse some data, and then you need to pass it to another like database, as just Xavier shared, or if you want to connect it with an IoT platform, or if you want to directly, I don't know, send your data to a Twitter account to report, I don't know, the status of the soil moisture of your plants, and because you want to your plant to talk, you can do that, and of course many other things like you can build anything you want with it. And as it is an open source tool as well, which is pretty awesome from IBM. And other thing to highlight over here is that like our devices can be easily connected using it, and Xavier is going to present it how he is doing it in a bit. So stay tuned to be on that demo portion. So Xavier, like, as I mentioned before, there were some changes in your work environment, and actually it is funny. It is super funny because I was checking our previous session and I made a question last session, and that question was, are you thinking, like, have you ever think about like quitting the corporate and then starting your own business? And your answer was like, okay, well, not sure, because there are things happening, and right now we are on that stage. So in which somehow you decide to take like this big jump to focus solely on the implementation of IoT systems. Like, could you share more about this change, and likewise, what kind of project are you currently working on, or are you planning to work on in the future?
Yes, this is true. After 2 years learning IoT and making lots of projects, from time to time, bigger projects, and everybody with customers and related to industry, I have seen a big potential on this. And I have seen that the way it's doing by my own way, not in the company where I was, since it's not the strategy they have. So now I have my own point of view. And can I participate in the projects that I find the most interest, and also make so innovative things. Okay, as I will explain you, because most of the time customers asked for some need or problem they have, and my most satisfaction was to develop a solution. Now it's so easy with all this technology, WisBlock, the RAK2245 gateway. This is so flexible and easy to make a prototype. Then and the solutions were robust enough to sell to the customers. I will talk about this new RAK device made from industrial shields. That it's a big tool. Let me show it. will try
Actually,
to
you have it
go
over there. Let me put it on the biggest screen so everyone can see it
Wow,
better.
that's a
if you
big
see
boy
the
toy.
RAK sign
Okay.
here,
Mm.
I always compare to a Ford Mustang or a
Wow,
Chevy,
it does look like
a
it.
powerful car. When you have the motor outside visible of the capot, so this is the same. This is a powerful device. It's worth to
Nice
have
comparison.
the sign of the motor of the powered by RAKwireless. This is an industrial Raspberry Pi using the 2245 module. It's really amazing. We'll talk
Basically, like it allows you to interconnect the different inputs that you are receiving from the main board, actually, and then pass it over to a LoRaWAN network server thanks to the concentrator.
Exactly. Not only it's a PLC with inputs and outputs, but it's also a gateway, a LoRaWAN gateway. So then you have all in one. A concentrator for all the signals abroad you have in your Raspberry Pi, and then you can send it to the cloud or take decisions, open, close digital outputs.
Outputs and inputs.
Great.
Basically, it's a LoRaWAN PLC. We can say that, right?
Yeah.
Kind of. Yeah.
It's a LoRaWAN PLC.
Exactly. So that's nice. That's nice. And can you share like an kind of an outline on how like industrial operations can benefit from the implementation of IoT sensors connected specifically via LoRaWAN? Like you have been a person who have been working with industrial companies and also like industrial devices, but and there you can notice the difference about the other communications technologies that are on the industry. So what is like that main benefit that we can have if we want to implement our solutions for using IoT sensors on the industry, but connected over LoRaWAN technologies?
Yeah, first of all, it's easier to interconnect. Interoperability between different machines, communication field buses, operating systems. You can do whatever you want in an easy way, because the industry normally it's a very rigid technology. Okay, a PLC can last for years, 30, 40 years working with no problem. But when you have to change something, probably you don't have the tool to modify the software. Well, this is a handicap. There are lots of industries with machines with old PLCs. And now what is most important is the digitalization process to have the production data, the machine data, to make KPIs for productivity, ratios, or for energy. Energy, this is another important matter now with the bill of the electricity that has risen a lot. Some factories had to stop some days of production because the bill is too high. They cannot afford it. And then the first thing you can do is to analyze, to monitor where are you wasting your energy and where you can optimize this. For example, to stop machines that they are running when they don't need to, or to change the running hours of a machine to different hours. Okay, there's also the penalizations you pay on a factory for the reactive, inductive, and capacitive energy. This is another matter. So this is so critical now, and it's so easy to monitor different lines, different machines with the LoRaWAN technology, because it's a low-cost solution with open source technology, and easily you can have in your screen a dashboard with all the power energy you are using.
And also I'm wondering about like, because in some case, like in some way, we can monitor our like factories. We can, let's use factories as an example, with different kind of technologies, and have the ability of push that valuable data to the cloud to be able to analyze it, and then be able to make smarter decisions based on the data that we are getting. But what do you think about the low power consumption of the devices, which is one of the main keys that LoRaWAN have on their technology? Like, more than an easy to connect technology and easy to get started and everything, what do you think about the power consumption of the devices? Do you think
Yeah,
this is something that is valuable for the industry, or it's more that we need to use like connected devices for the environment we are deploying them?
well, this is a great advantage of this low power technology operated with batteries, because then you don't use so many wires to plug the device. Normally, for example, for a machine, you just need 2 wires for the Modbus communications, and you forget, because you don't have even to power the sensor or the Modbus to LoRaWAN converter. You just use its batteries, so then it's great. You can spread on a factory, you can have hundreds of sensors to measure.
Completely.
Wireless. You don't have to use wires.
Yeah, like, imagine that before, like, if we're talking about like many years ago and wanted to do something like wired, like, imagine the meters of the long of those wires that the long of those wires that we need to be able to interconnect one machine to another. And right now you can do it by using like these devices, and establish a communication in range of kilometers, just thanks to this low range and low power technology, which is LoRa, which is pretty nice. And of course, using LoRaWAN to process all the data and be able to pass that information over a monitoring service that allows us to have a visualization and a study of the data that we are getting, to then be able to take the smarter decisions. For sure.
Yes, excuse me, Maria. I have an example of a factory where we had to monitor 7 electrical cabinets, 4 variables for each cabinet, so 28 variables. This is energy, instant power, reactive inductive energy, and capacitive reactive energy. And the customer had all in a screen, and it's amazing. He had no install any wire. The cabinets were separated 500 kilometers in different locations, the other side of the street, because there are 3 different buildings. Imagine all the wire that has been saved with only 1 gateway, and all in 3 days was running and installed with database and visualization.
Amazing.
Can I ask a question? Like, with your experience, is the industry early in adopting LoRaWAN, or do you think it's already well developed in the industry space?
Well, first of all, they are afraid.
They are afraid.
Radio technology will bring trouble. They don't know how robust LoRaWAN is, and also all the advantages you have to integrate. Because normally they think only on peer-to-peer communications.
Yes, that's how they
another
think.
Idea, completely different.
Yeah.
And they also should use more edge computing, like a Linux machine close to the machine, to have the data available through MQTT inside of the factory. This is also important. You don't have problems with cybersecurity if you keep inside of the network with the factory.
Mhm.
And it's very flexible, and I think little by little, for example,
We're going
Schneider
to
Electric.
change. We're going to change the industry.
Yeah.
Actually, what is the
Siemens are
reason he made that big jump,
pointing.
right?
Yeah. All the big manufacturers are pointing to IoT, but it's a slow process.
It's a slow process, agree.
Yeah, for sure. There are some like big corporates, like they are like like partnership with different companies in order to arrange that. One that it comes to my mind, I don't know if you know about them, but it's PTC.
Yeah, PTC is a software company, isn't it?
Exactly. They are a really big software company, and they have, if I'm not wrong, they are already have some models to interconnect different IoT gateways into it and easily extract all the data from these corporate, industrial devices. It's super interesting. Maybe we
Right.
can evaluate what we can do together with them.
Yes, sure.
For sure. So yeah, well, you have been implementing different projects so far during these past 3 years that you have been like thinking with the technology, and also like how you getting started with technology was super nice. Like to hear that story you shared over our last conversation, like that was next to the LoRaWAN community in your region. Then you start meeting people, start thinking about the with different projects, and now you are here. But can you share like about the different like projects that you have been developed so far using this technology, or if there is some like other important milestone that you would like to share with us today?
Yeah, I have implemented a Schneider smart cabinet, or they call Smart Link, to LoRaWAN. So normally you have all the information about the circuit breakers, status, or you can even open and close circuits from a Modbus communication systems, and then I pass it through LoRaWAN. For example, this device you already know. It's
7431.
great product,
31, yeah.
both in serial or in Modbus TCP.
Bridge.
Okay. This is one. With the cabinets, you can not only control machines, also the lightnings on buildings. So
Okay.
this is for building automation, imagine. Okay. I have also implemented Modbus TCP to LoRaWAN because it's not existing. The one I have showed you is a serial Modbus. But if you have a Ethernet TCP/IP Modbus based, it's not existing in the market. You have to build it with one RAK module that it's like a Raspberry Pi
using a shield.
A shield but it's not a gateway, it's a node.
It's a node, yeah.
Then you turn your Raspberry Pi on a node, and you can easily translate from Modbus in the Ethernet port to LoRaWAN. I just use a Node-RED and a file to store. First, I take the data from the machine, I store on a file, and then every 10 seconds, 20 seconds, whatever you want, I get the data from the file, and I send with the, for example, RAK library of LoRaWAN, the data to the gateway. Okay, there's another project I have done. And we also have done the Step Up project. This is a European research project to improve the carbon footprint of a building, because when you make a revamping or you make an old building, you make a lifting to have it again in a new shape, but you also have to use materials that are environment friendly and to reduce this carbon print. So then you have to make measurements before and after revamping the building. And this is what this project, you can find on the web, like a step-up project. And we were measuring CO2 and also the heating. This building had a central heating, and we used these kilocalories meter counters in LoRaWAN. Very easy to deploy. You just press a button, and in 10 seconds you have the date of heat in your application in your network server. And then I also have developed, also with this same rack, serial to Modbus again. With this device, I have developed PLC to PLC communications. You put this device in the emitter PLC, and then on the other side, you put RAK2245 gateway with an Ethernet port. And then you can access the receiver PLC easily in Modbus. And because Schneider Electric was contacting me, they have invited me to go to the headquarters in Barcelona to talk to the engineers, because they needed those solutions for example, wind power parks, and also for pump control remotely, and so on and so on. And they will try to start with these technologies. And also pump level control is also a project. And also the pipeline project that I will explain today.
For sure. Actually, we're going to have like a lot of detail about it. And also, like now that you like mentioned all these kind of projects that you have been doing, I would like to also share here over the comments. You can find a YouTube link, which is a link from a channel that is that Xavier has, that where he present a different demos of the projects he has been doing. So there you can find a little bit more about all the things he just shared with us. In case you want to explore more, and if you have like any doubt, feel free to reach out to him directly over his LinkedIn account, or that you can find it on the video description, or directly over his Twitter account as well, which is Xavier underscore telesis, as you can see on the banner name. So I think like you give us a really good like a brief of everything and the different projects you have been implemented. So we can jump on that presentation and demo that you prepared for us today. So let's jump into the tech. What do you think?
Yeah,
Go
let's
ahead.
go directly into the presentation. Great. Let me open this. Yeah, this is can you see it?
Yeah, we can see it perfectly.
I will put this screen so I can see what I'm going to explain you. This was a customer request. The customer works in the maintenance of gas pipelines, measuring the temperature in different points. As you can see here in the numbers 0, 1, 2, 3, those you have different stations where they measure the temperature. Why do they measure temperature? It's related to pressure, because as you know, on a gas, there's a law that P per V, nRT. So if you know the temperature, you know the pressure, okay? And it's an important factor. So they use PT100 sensors to measure the temperature, and they use data loggers, but they don't have the way to get the data from all the points to the central station, and they do it in 4 days. We will see it. They wanted a solution, and I thought LoRaWAN is the right one for this. Okay, so we'll see. This use case was done with the RAK2245 based gateway, It's a Raspberry Pi based gateway, and also WisBlock. Okay, the idea is to chain. I will explain you to chain the data from one to the other. Let's go to the next slide. Excuse me. Yeah. Okay. Here you can see profile and altitude profile, and the customer has some requirements. They had to measure in different points with no infrastructure, no internet, no 3G, no SIM cards, no, because they are everywhere in the world normally with no inhabitants. It can be a cold place or in the middle of the desert. There's nothing. So no main supply. This must be battery operated. And it must be a light portable equipment. After 4 days, they dismantle all the stations. They can have up to 9 stations. So after 4 days, they have to dismantle it. So it has to be an easy plug and play equipment and also light. The segments may have from 2 kilometers to 30 kilometers, each one. So you have 2 kilometers here, let's say 2 kilometers here, or even more. And if you put a gateway, as we normally do with TTN or Helium, first you need internet connection. It's not this case. You can use a private network. Okay, you can use this private network, but only with one gateway here. For example, in the top of the mountain, that you will cover this area, but behind the second mountain, this is a wall. You will not see after that wall. This is why you have to solve this. If you had an internet connection everywhere, you just install different gateways everywhere, and that's all. But here you cannot do it because all the gateways would not be connected to a network server because nobody will see them. They are isolated in the middle of nowhere with no TCP/IP connectivity. Okay, so here the idea is to use the private network, even with cheap Stark or with TTS, for example, running on the Raspberry Pi, to get the data from the neighborhood and to pass to the next station in a series, like a witness going in the races. Okay, and this is the idea. And let me show you next. This is the central station where they have the central computer, but not sure if they have internet. But if you have a computer, you can access your network server that must be locally here installed, the central network server. But as I have told you, we will use a network server on every section. It's a strange idea, but I will explain why. And how is the customer doing this now? They use this data logger. It's nice because it's little, battery operated, IP67, it's ruggedized. It supports minus 25 to 85 degrees, but it has no connectivity. You only can, after 4 days, you have to go with a computer, with serial port. It's protected, it's not open protocol, because I would connect this to the Raspberry Pi and that's all. But no way doing this. Okay. If something goes wrong, after 4 days, you don't have chance to recover the data. And you have to make 4 days more of measurements. Okay, and yeah, this manufacturer has a solution with mesh and TCP/IP. Very interesting that the nodes find themselves between each other, but only 100-meter distance between nodes. This is not our case. Okay, so the alternatives are those one. First one is satellite connectivity with LoRaWAN, which is low cost and open source, but I had not yet access to Lacuna Space samples, for example, but this would be a nice solution. Other solution would be the existing radio links. They are point-to-point, but you can build with face-to-face links, a chain to connect all the stations. But, well, I don't know this technology so much, and I had no access to easily make prototypes. And also the specifications are 15 kilometers between each stations maximum. And here we have up to 30 kilometers. So this does not fit requirements. And also the voltage is PoE, power over Ethernet. So this is 48 volts. With batteries, it's more complicated. Okay. So LoRaWAN is the solution, definitively. But you don't have a repeater in LoRaWAN. This is what we needed here. If I would, you need a repeater to send a message from one gateway to the other. This is not existing in LoRaWAN. So this is why I have had this idea, and this is a LoRaWAN solution that it's, of course, low cost, plug and play, has to be. All the stations equipment has to be the same. So the customer then does not have to lose time entering nodes in the network server and configuring. This is just powering it up and it will work, as I will show you later in the demo. Okay, standard equipment we have here. And of course, we're independent from telecom operators. There is no telecom operator here in the pipeline. The disadvantages is you have different frequencies for each country. So then you should have different models depending on the country. Okay, the temperature conditions we should check because the rack gets too warm, especially if you use the RAK4. The Raspberry Pi 4. I think it's better here because you don't need so much computing power to use the Raspberry 3 Plus because it's less heating the device. And also in the cold, let's see how this will afford the cold. Okay. Also, you would need a hard disk instead of a SD card to have it more robust. Okay. Also an IP67 housing, because as I have said, there's no LoRaWAN repeater. Okay. This is the main data logger. Okay. And this is the idea. It's to connect one data logger with a gateway to get data from the neighborhood and to send via the serial line to another node that will put this to LoRaWAN to the next gateway. Okay, in making a jump from station to station. Then you need well, if you use this industrial shields equipment, you can power up directly from 12 volts battery. You have 5 watts power consumption, and you can run with a 12 volts, 12 ampere hour battery. You can run for 30 hours. Okay, if you want 4 days, you would need from 3 to 4 batteries of 12 amperes hour. We have checked it in the presentation later. I will explain about some tests we have done it. And then this is the temperature sensor with an interface to the Raspberry Pi. This is the system. Optionally, you can use a solar power panel, but I think the customer did not want this. So just with the batteries, it's enough. And this is the idea, to have one station, the central, where all the computers are here. Then the next station with the data logger and the temperature sensor, and so on, until you can plug the requirements were up to 9. This is the Industrial Shields Raspberry Pi gateway based on RAK2245 we have talked about. And this is the idea. This is the software architecture. You just have a gateway concentrator here, and you install on the Raspberry Pi. It's very easy with the RAK web page. You just get the image on a SD card, and you just directly choose cheapest ARC. You just have it, and you declare on this network server the surrounding station. So the last WisBlock you have in the neighborhood, and then you use Node-RED, because with Node-RED we get the data we receive from the neighborhood WisBlock, and we inject in the serial port. So the USB, directly you plug a cable, you are just powering up this WisBlock. This is great because you are powering and sending the data with same cable. And just easy as sending a string with the temperature data you want to send to the next station. But temperature is also registered here in the data logger. Okay, I have been using not the PT100 temperature sensors in the case study. I have used the CPU temperature as a data to send. Okay, and also the timestamp. And this is using the WisBlock, the standard one. I think it's the 4630 LoRaWAN node as a standard. Just you take the sketch from the RAK web page, and you just modify, instead of sending hello world, you just send a string, any string that is coming from the serial port. Okay, this is how you make a LoRaWAN repeater. It will only repeat the data that you program it to do it. Okay, so this is like a filter. It will filter, will only output only the data you want to send to the next station. And here is the example with only one. Well, on the central station, we have used the things stack because we wanted to try how it's working both network servers and both gateways so close to the other. In the real life, you will have the gateways separated, but on the workbench, you had all the gateways all together, and really they work without interferences. You don't lose packets here. Okay, and this is the message that we transmit. JSON message with all information about the number of the data logger, the variable 8. Well, I will transmit temperature here, but it's just the data, and the timestamp. Okay, the timestamp when this user receives the data from the data logger. Here is the WisBlock connected with serial line to the gateway. Okay, here you have the applications and the device name on this network server running here. And here you have another application running in this network server. Okay, I guess it's clear. And here you have an example what has been tested with 4 stations. So we have the idea is to have same device in all stations, okay, with this topology. Raspberry Pi Plc based on RAK2245 with a WisBlock in all of them, okay? And let's go to the next. Here you see all the message that it's growing in length as soon as the message reaches the destination. Because of at the beginning, you will have the data from first data logger. This is not at all data logger, but you should use a Raspberry here as the other nodes. But just for the use case, we used a node. We transmit temperature. Okay, so the second station takes this temperature and adds a timestamp, and also takes the temperature here locally, in this case the CPU temperature, and then we send this message to the next network server. Okay, here we add another temperature. This is the temperature 1. Okay, and send to the end station where you receive 3 temperatures and 3 timestamps. Well, the last timestamp we introduce as soon as we receive the package. And this is working. Okay. And let's see here. We take a look at the station number 1, network server in ChipStark. We see the WisBlock number 2, which is this one. This WisBlock, we see the data arriving as a uplink message. Okay, from here to this point. And same we do with the temperature, the last number 3 station, we arrive to this. Okay. And for example, also you have the data logger on each station. You can install easily in Raspberry Pi InfluxDB database and Grafana. So even you can have a fantastic tool to get the data locally or when you are at home with all the equipment. But also you have all the data at the station 0 from all the other stations. Okay. Here you have an example of the station number 2. Same, again, a network server in ChipStark with this device sending the data. Okay. And here is an example of the Node-RED program that takes the data from the gateway and injects to the serial node. And I have installed something like a watchdog timer that tells you that the station is dead. And this way, it auto-adapts. The system is able to make it running without configuring. Just power it up, equal if you have 2, 3, 4 stations, no problem. You just have to have the software installed on each of them. Okay. And this is the example of different messages when you plug. So we arrive, we plug first station, then we plug second station. After some time, it starts transmitting, and finally we plug third station. Okay, this is why I want to show you. And the same if you unplug. Okay, it has an auto adaptation. And yeah, finally, in station 0, you have I have used in the cloud an IBM Node-RED recovering the data from the all stations. Here you have 101. This is not degrees, it's a distance. Okay. And you have also the database with all the data and the 3 timestamps. Okay. Let me show you the demo. Now I have to change of screen. So I stop sharing the screen.
Yeah, you can stop it and then select the other window.
Yeah.
And that's it.
Now I start sharing again. This is the network server from TTN. Yeah, this one. So do you see a screen with? Yes, this is the things stack network server. This is running on the cloud, but you could even run locally. Okay, I go to the first station. Now I plug station number 1. Okay, let's see how it will start transmitting. This is starting to, the LEDs are starting to blink. Okay, and we just wait for this node to transmit. Okay, yeah, like that. We just have a accept join request, and after some seconds, we will have the message arriving. We have to wait up to 20 seconds because it's sending with a period of 20 seconds. I have seen here that, yeah, here. Do you see DL1? This is,
yeah, we can see it.
Data logger 1 and the value. This is CPU temperature. Okay. So now the customer has plugged power up the station number 1 and automatically this is working. Now I will plug next station. Okay. Now we have station number 2. Okay. Running on. Okay. And we'll see that now we have to look, for example, at the network server. This is a ChipStark network server on station number 1. Okay, we're going to take a look at this device. Okay, and here you have, it has joined because I have just turned it up and it has sent a blink. So if we go to the central station, we see, well, this back should be only 2 and 1. Okay, but after next shipment, you have it right. This is a transitory, you know, always the transitions are complicated. It's better to be in permanent state. So this is the permanent state. Now you have station number 2 sending its temperature. I need the timestamp, and station number 1 and also its temperature, CPU temperature. Now I will plug the station number 3. I have it here. Okay, I will plug it. Oops. Just difficult to see, but I will turn it up, and there's an LED. It will blink. Yeah. Now we will have the data of these To see whether the data is arriving, we have to go to the station number 2, network server, which is okay. Yeah. I go to this device, and we should see when it transmits. Yeah, now we have the message, and this message has arrived from station 3 to station 2. Then we'll travel, so we will have to wait a little until it arrives to us, because it has 3 steps and separated 20 seconds each one. So we have to wait a little, but we will see after some steps how the message is arriving here, or should be.
Exactly.
At least on the screenshots, we had it. Okay. I see that something is wrong here, because it has
More than 20 seconds.
more than 20 seconds, and something is going wrong here. But well, as you see, the demo has the Morphe low, and it sometimes
No, that's fine. That's
sometimes
fine.
happens.
Yeah. Like those are the things or of live demos. Sometimes they didn't work at the end, but no, I think you could share like the whole overview of the project you was implemented, and that is like the thing of what we have, like these kind of spaces.
Yeah.
So it's like pretty cool.
I
And
stopped.
also I know that you prepare, like we have just a couple of minutes left, but I know that you also have been testing and working on a project which is pretty interesting, and it highlights so much the use case of one of our latest product, which is the Trackit.
Yeah.
So not sure if you can just give a brief overview about this proof of concept that you have building, and also like if you can give us as well as an overview of how would you plan to implement this new device that we just released on this project.
Yeah, let me share the screen again.
Sure.
Excuse me, that this one. Yeah. And this next slide. Yeah, do you see it?
Yeah, we can see it.
Yeah. So yeah, with RAK technology, you can use the GPS LoRa tracker for trial trekking races in the mountain to geolocate the runners or the walkers. And we did a pilot test together with a company with I'm collaborating. You will see later on. And this is the RAK2245 gateway, running 30 hours without stop, with a 12 amperes hour battery. Okay. And let's see, this is the examples. Well, you will have this presentation available. It's already in the LinkedIn post. So you could take more time to look at it. But basically, we have used 4 GPS LoRaWAN trackers and 4 gateways. Okay, each runner had a GPS, and we could track with the help of Node-RED running on IBM Cloud the race. This is the official path of the race, okay, on Google Earth, from the coordinates you get from a KLM file on Google Earth. But we could store on a database the tracked runner's path with this technology. And we only had some shadows of coverage because you have a lot of peaks, a lot of trees. You don't have coverage 100%. This is a matter of locate one gateway on each control. Okay. And we have used 4 our own gateways and 4 surrounding the neighborhood T10 gateways that were helping also. Before of the race, there we made simulation of coverage. You don't have to move to be there and to run 55 kilometers to know where to place the gateways. This is called Sirenet. It's a simulation tool that gives you a map of coverage to place the gateways. Okay, and this is an example of the race. We had a big TV screen with real time every 20 seconds, the position of the race. Here you see the gateway, okay. And here you see, because we used Node-RED, and you could open a dashboard of Node-RED. Everybody, on the people following family could open the mobile phone and see the status of the race. Here you have the last one and the first one. We have given the first one to the fastest runner, so we are sure they will be on the front. Okay, here you can see different screens of the TV, and this is the recorded track. When you see a straight line, this means that in this area we have no coverage of LoRaWAN, but here, for example, in the mountain, yes, you can see how accurate we had the tracking path. Okay, and this is on a database for all the runners, and you can check real time or after the race. This is a nice use case. Okay, we have learned a lot, and we have to make it next time with 200 GPS. See who will be the fellow to deploy those 200 nodes on TTN. And there are some pictures of the race. Okay, it was a great event with lots of healthy people. And they were walking or running for 55 kilometers. Okay.
Maybe for the next time, those 200 nodes will be powered by the tracking.
Sure. I would love it.
For sure. This is pretty nice. Well, kind of a LoRa walk with a big group, and also like having the ability to test like the technology you were implemented to get the benefit from it. So it's pretty nice, and also thanks for sharing it today with us. It's not like directly related to our technology in some part, but this is something this is a relevant use case that can definitely be part of the use cases that can be implemented with any device. So I think that's all for today. Like we cover all the things that you have been prepared for us. Also, like thanks for so much for preparing all of this and taking the time for being once again with here with us. And not sure, Jose, if you would like to add something else to the conversation before we conclude it.
No, thank you very much, Xavier. And I mean, I do recommend everyone to follow him on LinkedIn. He always posts the most amazing projects. So definitely keep track of what he's doing. Thank you.
Completely agree. And also you can check out the YouTube channel that I share on the comments. I'm going to be placing it as well on the video description. If someone is watching the video later, you will find it. So I think that's all. Xavier, before we conclude the session, would you like to share a message to our community of entrepreneurs, makers, and engineers like yourself?
Yeah, just don't be afraid to jump into projects, real life, with real customer projects, with a budget on it. because the success is granted with LoRaWAN. It's your rely, because it's very easy to implement, it's reliable, and the customer would be amazed about it. Once they start, they cannot stop putting more sensors and more sensors, because it is scalable.
Yeah. It's growing this year. It's growing a lot now. Yeah, definitely.
Definitely.
Yeah.
Definitely. No, amazing. Thanks once again, and we look forward to see any progress on the projects that you are currently working on, as well as to the new ones. We wish you many lucks and yeah, on all the things that are coming to you. And if you need any help from our side, as always, we are here to push you forward with anything we can. So yeah, I think that's all for today. If someone is watching this video later and have any doubt or concern about the things that Xavier shared, feel free to leave your comments and we will super happy to address your questions appropriately. And also make sure to subscribe to the RAKwireless channel before you leave the video. So yeah, I think that's all.
And finally, a message from our sponsor.
Oh yeah, for sure, please.
Tomorrow there we have a big drop of the minted miners. So at 8 a.m. Pacific time, which is super early. I know it's like you've got to set your alarm probably on a Saturday even. I do apologize. But it's, yeah. So we'll be dropping more US miners there. And that's it, yeah. So.
Thank you so much, Jose, for bringing us to our community members who are eager to get their miners.
More miners.
So yeah, there you have like one more opportunity, and of course we're going to be having more and more on the coming months as well.
Yeah,
so
including Europe and
in Europe,
UK.
All over the world. That is
all over the world.
But we'll see what we can do. But yeah, the idea is to keep expanding the network, and not just expanding it, is also to start implementing these kind of solutions that Xavier shared with us today on this network as well. So yeah, I think that's all, and we hope to see you next time. Also Xavier, and also for all of those who are watching us, enjoy the rest of your morning, afternoon, or evening, depending where you are. My best wishes to you all, and as always, happy hacking, folks. Bye-bye.
Bye-bye.
Bye, everybody. Thank you.